Hey good people, welcome back. This is Arthur Morris. In this video we are going to look at systems of inequalities in two variables. Alright, so to graph a system of inequalities in two variables, you will graph these as if they were regular equations first to find your points. That's how you find your points. And then the lines, if you have the or equal to bar, then the graph is graphed by a solid line. If you don't have the or equal to bar in your inequality, then it's graphed by a dashed line. And then we also have the shade on one side or the other. Now, since this is a system, we are looking for the compound or the overlapping solutions, and that's where the system solutions will lie. That's where the two solutions overlap each other. All right, so to graph 3x plus 6y is less than or equal to 6, you can do that one or two ways. Uh, let's go ahead and just solve for y and use the slope-intercept form. All right, so I see that I can divide everything by 3 on both sides evenly, so let's divide both sides of the equation by 3. Okay, and we're solving for y, so let's subtract x from both sides. And then divide both sides by 2. And 2 divided by 2 would be 1. Okay, so I see that I have a y-intercept of 1 and a slope of negative 1/2. So from that y-intercept, I will go down one place and to the right two places. Or I can go up and to the left. Up one place and to the left two places. And again, we have the or equal to bar, so I have a solid line. Okay. Now let's graph the second inequality. All right, so subtract 4x from both sides. All right, so my y-intercept is 8. And my slope for graphing purposes is negative 4 over 1, so down 4 places and to the right 1 place. And again, I have the or equal to bar, so that's a solid line. Okay, now the first inequality says y is less than. So I know I need to shade below that line. So the first line says y is less than, so I would shade below that line. The second line also says y is less than, so I would shade below that line. Now my solutions overlap right in this area there. So the actual solution for this set would be everything in here. Okay, let's look at another example. All right, this one we have x is less than or equal to 6 and y is greater than or equal to 4. So with the x is less than or equal to 6, we don't have the y variable, so that tells me we have a vertical line crossing the x-axis at 6. So I plot a couple of points, vertical points here. I said a couple, but plotted several. And it says x is less than, so I know my solutions are to the left of that line. But we also have the inequality of y is greater than or equal to -4. So again, I have the or equal to bar, so I'm going to use a solid line crossing the y-axis, horizontal line crossing the y-axis at -4. And that one says y is greater than, so I'm shading above that line. So if I'm shading above the red line and to the left of the black line, then that tells me that the solutions intersect in this area here. So any ordered pair that I chose, if I would choose an ordered pair in that solution set area, then it would be true for both of the inequalities. If I chose an ordered pair outside of that solution area, then it may be true for one inequality, one of the inequalities, but it will not be true for the other inequality. Okay, what about this one? This one we have to graph the solution of the system of linear inequalities. Okay, so we have a compound inequality, and we know that it's an and compound inequality because we don't see the word or. So we have x is greater than or equal to -2, and x is less than 6. All right, so again, we want to find the intersection of the two solution sets, and that's where our solution lies for the system. So here on the first one, we have x is greater than or equal to -2. We don't have a y variable, so we know that it is a vertical line crossing the x-axis at -2. And on this one, it is greater than or equal to, so since we have the or equal to bar, we will draw a solid line, so we will include all of those points. Now what about the x less than 6? Well, if it's x is less than 6, then again, we don't have the y variable, so we'll draw a vertical line crossing the x-axis at 6. All right, so for the x is greater than or equal to -2, greater than -2 would be to the right of the black line. X is less than 6, that would be to the left of the red line. So we see that our solution set is right here in between those two lines, those two vertical lines. Okay, let's look at this one. Here we have graphed the solution set of the following system of inequalities, and the first one is a parabola. We have y is greater than or equal to x squared minus 4. So we know that from the parent graph, this parabola shifts down 4 places. However, if need be, we can make a table for that. So we know if it shifts down 4 places, then our vertex is at 0, -4. So let's put the vertex in the middle, and if we replace x, 0 squared minus 4 is -4. Let's see, -1 and -2. If we replace x squared with -1, -1 squared is 1, and 1 minus 4 is -3. -2 squared is 4, and 4 minus 4 is 0. Now we know that there is symmetry about the vertex in a quadratic equation, in a parabola. So if I go one place greater than 0, then that's going to be the same, give me the same y value as one place less than 0. And same thing for two places. All right, so let's see here. We have 0, -4, -1, -3. Now, be careful here on my y-axis. It is counting by uh, twos. So we have -2, -2, -4. So -1 and -3 would be right there. -2, 0. Okay, 1, -3. And then +2, 0. All right, so that's the first equation. The second equation is a linear equation because we don't have an exponent of square, anything an exponent greater than 1 there, and everything is in the numerator. So x minus y is greater than or equal to -2. Let's go ahead and solve that inequality for y. So subtract x. And then divide both sides by -1. Now remember, when you divide an inequality, both sides of the inequality by a negative number, you must reverse the inequality symbol. Okay, so my y-intercept is -2, and my slope is +1 over 1. So from here, up 1 over 1, up 1 over 1. All right, we have the or equal to bar, so we need a solid line. And we need to shade. So my first inequality for the parabola said y is greater than or equal to x squared minus 4. If you're not sure, pick a test point. And again, the easiest test point to choose is 0, 0. So let's test 0, 0 to determine where we should shade for the parabola. So if I test 0, 0, we end up with 0 is greater than or equal to -4, which is a true statement. Therefore, I know I'm shading on the inside of this parabola because 0, 0, 0.00 is on the inside of the parabola. Now, for y is less than or equal to 1x minus 2, I know I'm shading below that. So for the parabola, I would shade here. For my red line, for my linear equation, I would shade here. And you see the solution set lies right in this area. Okay, so let's just graph the solution set, which is in between the line and the parabola right there. So here will be my solution set. Alrighty, good people. I hope you found this video to be helpful. I will see you on the next one. Thank you.